Hi everyone, my name is June.
And I'm Jennifer.
Today we have some really fun experiments to show you, and if you want to, you can try some of them at home yourselves. The first one is really easy, and you can do it at home if you have a coffee mug and an empty drink can. You can try and trick your family members with this one, so I'm going to try and trick Jennifer. Jennifer, can you get the can out of the mug without touching the mug or the can with your hands or your feet or your nose or any part of your body? And you're not allowed to tip up the mug in any way.
Okay. Let me see.
You're still touching it though.
Oh, okay. I don't know. No, I don't think I can, June.
Okay, so this is how you do it.
Ah,
Ta-da!
science.
Science. So what's the secret? What's happening?
I don't know, June. What is happening?
Okay, so it's all to do with the science of air pressure.
Oh, okay.
When you blow into the gap between the can and the mug, the force of the air squeezes the air that's already down there, the air that's already in between the mug and the can. It squeezes it and it puts it under pressure. The pressure increases. This high pressure air then pushes against the bottom of the can, and that's why it jumps out of the mug.
Very impressive. That's
Okay.
one to trick your brothers and sisters with, or your parents, I think. Okay, so now I'm going to challenge June with my own experiment. So for the next experiment, we're going to need some hairdryers. Here we go, June. Would you like to blow away? Here you go, there's one for you. And we also need some ping pong balls. So I wonder, can you guess what experiment we're going to do now? No? Okay, so it's a bit of a balancing act using the hairdryers and the ping pong balls. So you place the ping pong ball on top of where the hairdryer goes, and you turn it on, and it should balance. Whoa, that's pretty cool. Can you go higher? I wonder, mine's on the top speed. Woo! Pretty nifty. We've lost our ping pong balls, so that's okay. Okay, so if you want to know the science behind that, what's going on here is balancing forces. So gravity pulls us to the ground, so that's what makes us stand, how we're standing right now on the ground, and that's what's bringing the ping pong ball down. But the other force that's pushing it upwards is the hot air. So when those forces balance each other out, that's what causes the ping pong ball to float in midair, pretty much. So if the hairdryer was any higher, I think it would probably shoot up higher
Let's see
as
if
well.
I can turn mine up a bit higher.
Yeah, let's see. I think mine was max speed. Oh, no.
Makes you get higher though.
Yeah.
Ooh. It's pretty cool.
And then you can style your hair afterwards. So.
Okay.
All right. So try that one.
Now let's look at what happens when a volcano erupts. First, we're going to make a volcano. So this is the one we've made already. We used a piece of cardboard, an empty honey container, some sticky tape and some aluminium foil. So this honey container isn't empty, but it's just to show you what we used, okay? So every volcano has a pipe called a vent. So the honey container is going to be the vent, and a crater, which is the top of the volcano, the hole at the top of the volcano.
So if you come around here, it'll be this bit here up the top without the lid on. Yep.
So volcanoes are made of layers of rock or sand. So we're using aluminium foil to represent the rock or the sand. And you can paint it if you like. You could paint the foil. We haven't done it, but it's up to you.
And you can use other materials as well,
yeah,
like sand or mud if you've got it in your backyard, whatever you've got around. Clay, things like that. Yeah.
So what we did, we sticky taped the honey container to the piece of cardboard.
Just to
And we
secure
sort of
it.
made a bit of a frame with the sticky tape from the top of the container.
Okay.
And lots of long bits of,
Yep.
So we went on like that till we had a frame out of the sticky tape. You can use some thicker sticky tape if
that
you've
was
got
long
any,
enough.
some of the packaging tape. and then we wrap the foil around it. So that gives you the basic idea of how we made our volcano. So deep under the volcano, there's a big chamber called the magma chamber, and it's full of molten or melted rock called magma. So hot gas builds up underground and blows the magma upwards, and as the magma blows upwards, it gets even hotter, and when it's very, very hot, it's called lava. And the hot lava blasts out of the crater and flies into the air and fountains down the side. And the lava that runs down the side is called the lava flow. So we're going to now make the lava flow. Let's have a look. We're going to make our volcano erupt. So to do this, we need some vinegar, some bicarbonate of soda, and some food colouring. We used red food colouring. So we need to put a few teaspoons in there.
Bicarb.
Yep. And now in the same cup, put the vinegar.
Yep, fill it to the top, June, or?
Not quite.
Okay,
about
so
half a cup will do.
half? Alright.
And then put a couple of drops of
some food
food
colouring.
colouring.
Oh, I think it's already reacting a little bit in the cup here.
because
You
there's
can
still
see.
a little bit of bicarb that's in there.
It's going all fizzy. It looks like lemonade or something. Okay, and a bit of food colouring. Oh. Beautiful. Okay, mix it around.
Here we
Okay.
go.
Alright. Ready? Oh, there we go.
Oh, there's our volcano erupting.
Whoa. I wonder if I shake it up
yeah.
if it'll erupt a bit more.
Still going. So the lava
like
and
real
ash
lava.
can injure people and destroy their homes. And there are scientists who study volcanoes to try and accurately predict when they're going to erupt. And these scientists are called volcanologists.
Oh, wow.
So the next experiment we're going to be doing is to test what sorts of materials are best at protecting things from heat. And then we can better understand why volcanologists wear the types of suits they do while they are carrying out research. So for this experiment, you'll need 4 pieces of chocolate. So we had some Easter eggs still left over, so we're going to use them. But just any pieces of chocolate that you've got around the house. So we need to break them into 4 pieces. We need 4 even pieces.
4 even pieces. Okay, no worries. Oh,
Oh, very
that
good.
was a good break. Oh, whoops, bit extra. Oh, better eat that. Okay.
All right, that's pretty good.
Yeah.
So we're going to wrap one of the pieces of chocolate in aluminium foil.
Yep. Okay. There we go.
And we're going to wrap the second piece of chocolate in some plastic cling wrap.
Yep. All right.
We're going to leave another piece of chocolate unwrapped, just leave that as it is.
Yep.
And the last piece of chocolate we're going to wrap in some black paper.
Okay.
Now you can just leave this in the sun and you can keep checking it yourself if you're doing this experiment at home, and you can see which ones melt the quickest, and you can compare them. We're just going to give them a bit of a blast with our hairdryers to see which ones melt and which ones don't melt, or see what happens.
Might be good to do this in a bowl so they don't fly all over the place. Uh-oh. Runaway egg.
Oh, look at that one. The one without anything starting to melt. It's starting to stick to the plate already. Whoop.
So we're back with the results of our chocolate experiment. So we tested the 4 different materials. So the chocolate that melted in the shortest amount of time was actually the one that was wrapped in the black paper. So it's kind of gone hard now because we've waited a little bit of time, but that did go the fastest, and that's because black attracts heat. So I don't know if you've worn a black t-shirt on a hot day and you feel really hot in comparison to if you wear a white t-shirt. So you would not wear this near a volcano. The one that melted the least and the slowest amount of time was the one that was wrapped in the aluminium foil. So, it is a little bit melted though, which has gone on my finger. So volcanologists wear shiny suits to keep the heat from the lava, it bounces off of them basically. And you can have a look at what happened to the ones, this was with the plastic wrapping, so it's pretty soft. I don't think you'd want to wear Glad wrap next to a volcano. And this is what would happen to you if you were naked next to a volcano. So that doesn't look very good either.
Very good at all.
Yeah, so the one that stayed the most firm was actually the one wrapped inside the aluminium foil. Okay. So thanks for joining us for our chemical reaction heat special. And we hope to see you again soon for more fun science experiments. Thanks. Bye.
See you later. See you.
We use this book for most of the experiments that we tried in this video, which is available here at Brimbank Libraries. So if you'd like to order it, you can go online at brimbanklibraries.vic.gov.au, or you can call us up on one of the numbers listed here and order it for yourself or any other cool science books.